Okay, so now I'm going to walk you through some of the genetics examples that I have posted for you in Canvas. I'm hoping to do each one of these individually so that you can click on the ones that you need help with the most. Okay, so again, what you're supposed to do first is figure out what type of inheritance is it. Is it complete dominance? Is it codominance? Is it incomplete dominance? Is it sex-linked recessive, sex-linked dominant, or is it a blood typing problem, which is going to involve both codominance and complete dominance? So this is the first problem that you can go in and read for yourself. Because I see the words dominant and recessive in here, this is going to be complete dominance. We will not see those words in codominance or incomplete dominance because we don't have one allele that's dominant over the other. So I automatically know that this is complete dominance. So I need to see what phenotype is dominant over the other. So it says that brown eyes are known to be dominant and blue eyes are known to be recessive. So I'm going to go ahead and make note of that. And I'm writing it wrong, I'm sorry. Okay, both of these start with B, but we should be writing our key using the letter B to represent the genotype because brown is dominant, and ignore the fact that blue also begins with B. Okay, so remember, we figured out it's complete dominance. The next thing to do is to do our key where we have a genotype. And then a phenotype here. Okay, so we have to have at least one dominant allele to express the dominant trait. So we could have two dominant alleles and have brown eyes. We just need one. So we could also have one dominant allele, one recessive allele, and have brown eyes. And in the event that we have two recessive alleles, then we would have blue eyes. Okay, so Eddie has brown eyes. All right, we have two possible genotypes that could represent brown eyes, so we need to look for more information. And Sybil has blue eyes, so we can definitely determine Sybil's genotype because there is only one genotype for the recessive phenotype. So Sybil's genotype is going to be two recessive alleles because she has blue eyes. Eddie has brown eyes, so we know he has at least one dominant allele. And then it says, assume Eddie carries a recessive allele. So his other allele has to be recessive. And they just want you to predict their offspring. So this is a monohybrid cross where we just set up our tic-tac-toe board and see what the potential offspring are. All right, so we put each of Sybil's alleles here. Doesn't matter which parent you put there. I just happen to put Sybil's there, which are two recessive alleles. And we're going to put Eddie's alleles on this side here. And again, the goal is to determine what the potential genotypes of the offspring could be if Sybil donates a recessive allele here and Eddie donates a dominant allele. So you basically just match what would go in this box if each of the parents donated that particular allele. Just some nomenclature, how you should be writing these things is that the capital letter should always go first, no matter which direction you're coming from. All right, so these are their four offspring, and you can go in and count to the side or however you want to do. So let's see if we're talking about a dominant allele and recessive allele, another dominant allele and recessive allele. So we would get two brown-eyed offspring, and we have two with the genotype for blue eyes, two here. So they have a 50% chance of getting a blue-eyed child and a 50% chance of getting a brown-eyed child.